Alright, so the first thing we want to do is we're going to solve percent problems translating to proportions. So a percent is just a proportion with a ratio of compared to 100. So if I look at proportions, remember a proportion is just a comparison of two fractions, an equality of two fractions. A is to B as C is to D is how we compare the quantities. So one of the things I know that A and C, we want to look and compare those quantities across. They should be factors of each other. And B over D, when we look across, they should be the same factor of each other. So we're using equivalent fractions to kind of compare those quantities. Well, a percent proportion is a proportion that involves a percent as one of the ratios. So these are very common. Again, we're going to be doing a lot of proportions involving percents. So one of the things we have is a formula for our proportion. We have a regular ratio on the left side and then that percent proportion on the right. So P is the percent. And we solve so many of these that we actually name the different components of the ratio on the left side, what we're comparing. So A, we call the amount, and the amount is basically the part of the whole. So A is the amount, and B we call the whole or base. When we're looking at this, usually the base follows the word of. The amount is compared, the amount of is the part compared to the whole or the base. It's a part. So if we think of percentages, the percent P is the part compared to 100. So when we look across, one of the key things is when we look across, A and P actually represent the same quantities. So A is the actual value of the quantity and P represents the percent value of that quantity, percent value. But they basically represent the same quantity. So the first thing we're going to do to solve percent problems is be able to recognize the different components in the percent proportion. So what's the amount, what's the base, what's the percent? So for each of these, we're just going to translate these, and I'll write this percent proportion down again. So our formula that we use is a proportion where one of them is compared to 100. P is the percent, A is the amount, and B is called the base. So when we translate using our percent proportion formula, again, we're just translating. It says what number is 25% of 116. So we start out with a percent proportion. The easiest thing to identify is the percent. So P is going to be 25 of 116. So I'm taking a piece of 116. So that's my base. And so it looks like the what number is looking for the amount. So this would be a translation of that problem into a percent proportion. So we're just translating right now. Later on we'll solve, but let's try this next one. 30 is what percent of 90? So again, we set up our percent proportion. Now it's actually looking for what percent. So we're just going to replace in our formula that with P. Again, 30 is what percent of 90. Of 90 would be our base. And then 30 would be the amount. A. So this would translate to 30 over 90 equals P over 100. So again, it's just recognizing the different components in our proportion. So the last one, 27% of what number is 54? Again, would translate into a percent proportion. The percent is easy to identify, right? So that's 27. Now, here it says of what number, and then is 54. So of what number would represent the base, and is 54 then would be the amount. The 54 would be the A. So now how do we use these proportions to actually solve? So each one of these then we're going to translate first into our percent proportion. And again, our formula for a percent proportion, we have the P A over base, amount over base. So we're going to translate each one of these into a percent proportion, then solve using algebra to do that. So first of all, we'll translate this first problem into a percent proportion. So the percent, 8%, we're just going to use that, or replace that with 8. What number is 8% of 120? So the 120 would be the base. And it looks like I'm looking for the amount. What number is P? I'm looking for A. So to solve this, we can do a few things. All we need to do to solve this for A is to multiply both sides by 120. So if I multiply the left side by 120, that cancels, leaving just A. And then if I multiply the right side by 120, the right side by 120, I can calculate my answer. So with fractions like this, we can use canceling, or we could just multiply. So this would be equal to 8 times 120, which would be 960, and then divided by 100. And to divide by 100, we just have to move the decimal place back to the left 2 places. So A would equal 9.6. Again, we could use our calculator on this, but I kind of want to show us how to manipulate those fractions. So the next problem, we'll just translate this into a percent proportion. So the first thing we'll do, translate into a percent proportion. The percent, 65%, will replace that P with 65. Of what number is 52? So again, of what number is looking for the base in this case, and then is 52 would be A, 52. So anytime we're looking for the base, the first thing we're going to do is take the reciprocal. So let's look at the reciprocal of each. So if I take the reciprocal of B over 52, or 52 over B, I would get B and then over 52 equals, and then the reciprocal of 65 or 100 would be 100 over 65. So once I take the reciprocals, then I can just solve by multiplying both sides by 52. The 52s would cancel. I get B equals, so again, we could just plug this into our calculator, or we could notice that 65 and 52 have common factors of 13. So 13 would cancel, leaving a factor of 5, and 13 would cancel with 52, leaving a factor of 4. So now the 5 and the 100 cancel, leaving a factor of 20. So the only thing left is 20 times 4. B would equal 80. All right, the last two problems is looking for the percent, and I have them both here. So again, we'll set these up as a percent proportion. So we're we're looking for the P of 40. So of 40 would be the base, and then is 8 would be the A. So this would be 8 over 40. So to solve this one, we could just multiply both sides by 100 and then simplify it. Or we could simplify this fraction first. 8 over 40 is the same as 1 over 5. So we'd have 1/5 equals P over 100. And then if I just multiply the bottom, if I notice 5 goes into 100 20 times, 5 times 20 is 100, then multiplying the top, I would see that P would equal 20 times 1, or P would equal 20%. So after you get it into a proportion, we could solve many different ways. I just don't want to be very consistent in how I solve them. I want to show different ways to manipulate the fractions, and that gives us better number sense of how the percents work. So one thing I want to be careful with is to make sure I don't just put in my percent proportion. I don't want to just put the smallest number over the biggest. I really want to make sure I understand what the base is. So 414 is what percent of 180. So of 180 is the base. So in this case, the 180 goes into the denominator. 414 then would be the A, or the amount. Okay, so to calculate this, I'm just going to use a calculator for this, but I'm just going to multiply both sides by 100 to get P. And when I calculate 100 times 414 over 180, I'm getting, so when I calculate this, this comes out to be 230. So that's the P, so therefore it'd be 230%. And that makes sense because 414 is much bigger than 180, so I should be getting more than 100%.